time shifting property of Z transform. What is time shifting property? A time shift of k in x of n max multiplication of z to the negative k in x of z. Look, if Z transform of x of n equals to x of z, then Z transform of x of n minus k equals to z to the negative k times x of z. That's what time shifting property tells us. That look, a time shift of k, if you have the shift of k in x of n, it makes multiplication of z to the negative k. You're gonna get something extra, which is z to the negative k with the Z transform. What is my x of z? X of z is my Z transform. When you look at it mathematically, if Z transform of x of n equals to x of z, what is my x of z? X of z is the notation for the Z transform. If the Z transform of x of n equals to x of z, then Z transform of x of n minus k equals to z to the negative k times x of z. Remember, n minus k means the shift of time in x of n. I have x of n, but here I have the shift of k. So the Z transform of x of n minus k, which is the time shift of k, it makes multiplication of z to the negative k with the Z transform. You will get z to the negative k extra with the Z transform. This negative k depends on this variable. You can put any variable. For example, sometimes you may see that there is n minus a. So you're going to have z to the negative a. Sometimes you may see that it is n minus c. So you're going to have z to the negative c. There may be any variable here for the k. But since we have n minus k here, therefore I have z to the negative k times x of z. That's what time shifting property means. So let me check a short proof for the time shifting property. Proof. We're going to do a mathematical proof for the time shifting property. Z transform x of z equals to summation of x of n minus k times z to the negative k, where n starts from negative infinity up to positive infinity. Remember, for the x of n, I have x of n minus k. So there is a time shift of k in x of n. You just plug in that x of n minus k. For the x of n here, it is the equation of the Z transform. Now let me let something here. If I let m equals to n minus k, this implies that m plus k equals to positive n. Just let n minus k equals to m here, which implies that n plus k equals to n. For n minus k, I'm going to plug in m here. For n, I'm going to plug in m plus k here. So the equation will be x of z equals to summation of x of m times z to the negative into m plus k. Just plug in n minus k equals to m, and n equals to m plus k here. Now if I open the parentheses, I will have z to the minus m and minus k. It equals to z to the negative k into summation of x of m times z to the negative m. Look what I did. Can I write z to the negative m minus k equals to z to the negative m times z to the negative k? Yes, that's what I did. If you open the parentheses, you will have negative m, and then negative times positive will be negative. So you're going to have z to the negative m minus k here. And then I wrote this term equals to z to the negative m times z to the negative k. Look, here my base is z. Here the base is z. So they have the same bases. After adding their powers, you will get the same z to the negative m minus k. So whether you write the expression in this form or in this form, it is absolutely one thing. But I wrote it in this form. So for z to the negative m into m plus k, I will have z to the negative m times z to the negative k. Since it has a product, so I just took z to the negative k out of the summation and put z to the negative m as it is. Now when you look to this expression, it is the formula of the Z transform, which is summation of x of m times z to the negative m. So can I write z to the negative k into x of z? Here z to the negative k is this one. And this is the formula of the Z transform. So I'm simply put x of z for this expression, because the equation of the Z transform equals to x of z. So plug in x of z here. Now you might be confused that why I have m here and m here, but there is n. Suppose if I let n equals to m, You just suppose n equals to m and n equals to m. So you're gonna have m equals to negative infinity and m equals to negative infinity, which equals to x of z. We just let m equals to m. Nothing difficult here. So there I got the final proof. According to the time shifting property, if you have the time shift of k in the x of n, we're gonna have the product of z to the negative k with the z transform. So there we got z to the negative k times x of z. And that's what we were trying to prove here, that when you do the time shift of k in x of n, its z transform equals to z to the negative k times x of z. And we saw it here in the mathematical proof.